If every like 3 to 4 weeks you haven't decided like what we're building is totally wrong, we need to scrap it and start something else, you're probably not spending enough time on getting these customers. We ended up landing on something that it then took us another year to realize was not the correct form factor for larger scale deployments.
Today, we're excited to welcome Eno Reyes, co-founder and CTO of Factory, creator of autonomous agents called droids that handle product and engineering tasks for teams. With years of experience in AI and product development, Eno previously worked at Hugging Face as a machine learning engineer, deploying, fine-tuning, and productionizing large language models for enterprise use. His background spans neuroscience research, AI engineering, and building tools that change how humans and AI collaborate. Currently at Factory, he's shaping the future of software development through human-agent collaboration. Before building AI agents, Eno worked on brain-computer interface research. In this episode, we dive into his journey from studying brain to building an AI-driven developer platform and explore his vision for the role of engineers in an era of autonomous agents. 50 years ago, you couldn't have built Salesforce. With this complex technology that we have, we're not too far away from something new coming about that could not have been built 5 years ago.
We're going to build things in the next 5 years that would blow the mind of a software developer 10 years ago.
Eno, we're seeing a wave of startups and headlines declaring that AI will replace engineers. What's your take on this narrative?
This is a great question, and one that we hear a lot since we're building, these sort of agentic systems. We call them droids that help delegate a ton of different tasks, right? Tasks that typically would have been done manually by engineers. I think that the bigger sort of trend that we see is driven by a lot of different things. First, there's an anxiety around sort of the way that work was done before, and seeing a lot of AI systems be able to contribute at a level that is like at or above human level. You combine that with the sort of trends of exponential capabilities growth. The sort of recipe for that is, well, there's clearly going to be some point where the thing that I currently do is no longer requires me. What we've seen in the past, right? Every time there's been this sort of technological transformation, is that there are a number of roles that, transform very lightly, a number of roles that transform rapidly, and then there are definitely roles that sort of disappear. Software engineering does not feel like one of those roles that is going to disappear. And in particular, the sort of idea of building systems and defining constraints and really understanding what it is that needs to be built. These are all things that human beings actually are quite good at. And a lot of people became software engineers because of their systems thinking ability. Now, writing lines of code and memorizing syntax, right, has actually sort of not been required for at least a couple of years now. A lot of languages like Python are very friendly for beginners. They help you write code in a very almost like natural way. If you actually think about, writing a couple lines of Python, it almost looks like English, right? Like, while this thing is happening, I want you to run the function, go do thing, right? It's like sort of almost natural language. And the sort of transition that we'd expect to see, though, will ultimately be from human beings doing sort of like what we currently think of as coding and moving more towards delegation, where a human being is sort of delegating tasks to AI systems and sort of composing those delegations into bigger picture projects. And that means that, yes, the role will look really different. But we think that there's currently, maybe a 10th or 100th of the number of software engineers that there will be in the very near future, because AI tools are really democratizing access to high quality software capabilities.
So I guess what you're saying is this evolution just basically means that it gives a software engineer new tools at their disposal, but fundamentally the fundamentals of a software engineer, the first principles thinking, is still profoundly required.
Oh yeah, definitely. We talk a lot about taste, where there's a certain taste and a certain systems thinking mentality that's required to build good software. And that is always not a matter of, is this functionally correct? Or, I think AI is really good at, you give it feedback, you give it tools, it can write code that can pass tests. Mm-hmm. But passing a test or being correct is not the same as being good software. A lot of the principles of good software are still going to require human beings to sort of maintain and build the larger picture ideas, and then agents can definitely help accelerate that, though.
I mean, it's a very interesting topic, right? Because there is a plethora of companies that are claiming that they will replace humans, like outright replace the entire organization of a company. And it is creating somewhat of a fear within engineers, especially ones that are coming early into the industry. I think entry level engineers are now wondering what their career is going to look like. What do you have to say to those people?
Well, I think that there's sort of two parts to this. So the first is, I'd say to them, you have to think about the incentives of saying things out there, right? A lot of people say a lot of different things in markets, right? And you should always sort of take a lens, especially the public companies, take anything those CEOs are saying and really sort of translate what is the outcome on share price that they're looking to sort of create, right? When a company lays off a couple percentage points more people, it's sort of a bullish sign sometimes. When you lay off too many people, that's bearish though, right? And so any sort of deltas in the number of layoffs, in your performance, in your capabilities, your strategic goal shifting, there's always sort of an opportunity for you to buffer that by saying, well, also keep in mind, AI is now here. And so now we're, actually us failing to execute on this business unit, sort of that loss of people, we'll think about it because as more of a efficiency gain from AI, right? So I think that there's always a dynamic on the public market side. For the private markets, think about who actually says these sort of things. It's mainly the leaders of foundation model AI companies, right? Who are selling a product to said CEOs and the like. If you had access to one of the maybe 4 or 5 major foundation models, you had leadership responsibilities, then it's very natural. You want to fundraise, you want to make sure that people see you as the winner in the space. And what is sort of the prophetic end state of AGI is, well, it's a utopia where no humans work. And so you say, hey, don't worry, that's coming very soon. So how about we raise it $100 billion valuation instead? And so I think that there's sort of a pretty bad incentive to sort of spin this narrative. When you actually look on the ground at college kids that, come in to a new job, the reality is the job market right now actually is slightly tighter than it was, let's say, 2 years ago. But I think that there's a lot of other sort of implications on this. We sort of had this huge boom in the post-COVID era, and then a lot of those roles started to get filled. And now the sort of major tech capabilities are changing. If you are someone who knows how to use AI tools, then you will end up being much better than even a senior engineer as somebody who's fresh out of college. And that's something that we've seen a lot is there are just stars who are coming out who are not even necessarily the sorts of people that would have been stars 5 years ago, right? It's not, I have memorized every single algorithm and I know how to invert a binary tree 15 different ways. And but instead it's people who just say, oh yeah, well, I know how to vibe code and I understand how to command an agent to build the thing in a way that is reusable. And those are the people who are starting to kind of accelerate past their peers. What's cool is this is actually, in many ways, a different but potentially easier skill to pick up. It really just requires you to invest time in using the tools rather than memorizing a bunch of books.
It's interesting, right? You hear this phrase a lot, even with, in relation to non-technical folks like myself, which is learn how to use AI. There's always this question, what does that even mean? Because am I just learning how to prompt better? For the non-technical folks, what does that even mean to learn how to use AI?
No, this is also something that, it's funny because learn how to use AI is sort of the learn to code of 5 years ago as well. I think there's 2 layers to it. The first that you mentioned is a lot of it is just clarity in communications. We're not used to treating computers as computers have historically been either very, very fuzzy inputs, you can Google search sort of really anything with a word or two, and then you get results that somewhat match, or maybe you ask it a 1-sentence question. And then on the other end, programming is extremely precise instructions, right? So you sort of have 2 ends of the spectrum that people are used to interacting with machines. We're sort of in this fuzzy in between where maybe the best way to think about it is you're speaking to like a highly competent out of domain expert who you're asking a PhD in in communications to write code for you, except the moment you give it to them, they'll actually write extremely competent code, right? And so you sort of have to speak to the system in a way that's very clear and concise. And then it will do almost exactly what you ask it to do in the vast majority of cases. So I think it's really that aspect is you have to mentally model what this other system has access to, the information it has access to, and then assume it to be extremely competent. And then you kind of go from there. Honestly, I think you just get this from using a bunch of different tools. Once you've used like 5 or 6 or 7 different AI tools, you will really start picking up the nuance in how different interfaces, different tools sort of give you the same intelligence behind the scenes, and you'll be much more competent.
It's interesting, right? So if we go back and kind of unpack the role of a software engineer, as you said, the role's not going away, but I guess we both can't deny that it is going to evolve. What does this new evolution look like? What does the new software engineer look like, especially like for someone like yourself building your company at Factory? When you're looking at hiring for your company, what are you looking for?
I think that the things that are definitely going to stay the same in terms of personality traits and sort of motivators for software engineers, systems thinkers, we kind of already talked about this, like taste and communication skills is about to really increase in demand. Like if you are a clear thinker, someone who can communicate very concisely what it is that needs to be built. And at a high level, all software engineers are sort of like building systems that are defined by their inputs and outputs, right? Like, hey, I want a server, and in comes this data, out comes that data. And then you have a lot of folks that focus on interfaces that help guide the input, right? You have people who build distributed systems, they build hardware, right? Or the software that powers hardware, right? And even those, right? It's all about input, output with some set of constraints. The transition that will occur is if you have systems where you just speak clearly to them about what you want built, then everything becomes about defining what it is that you want built, right? And so a lot of the sort of work that as a human you'll be doing is I want to define the boundaries of what constitutes correct and incorrect for a solution, right? I want to say this is what input looks like. This is what output looks like. You can explore with AI all the edge cases. You can still use it to sort of collaboratively build this vision of what it is that you want built. But that sort of constraint setting is ultimately what a software engineer is going to continue to do. And what that means, though, is like folks who are maybe technical product managers or people who are like design engineers, right? This is going to start to become a lot more of the norm, is a blending of roles where there's no longer really a reason for you to be just an infra engineer or just a product manager or just a designer. Like you now have the ability to sort of become someone who works on all aspects of building a piece of software. And that means generalists are about to become way more valuable as well. Honestly, you'll be able to go even deeper as a specialist than you ever have before. I definitely think that generalists in software that blend the lines between sort of product and engineering and UX are going to become extremely high leverage with AI.
How have you seen the high performers, in the industry or in your company? How have you seen them leverage these tools to make more impact than perhaps 2 years ago?
The top performers across the board are moving from serial work to parallel work. And that is really probably the biggest challenge for somebody who has previously built software, because it is ultimately a totally different workflow. Right? Mm-hmm. Most software engineers are used to this inner loop of software development where you go, you write code, you test the code, you lint it, you validate, you make some modifications, and you sort of do that in this inner loop, right? When you exit that, you go to the outer loop of software development, which is what is it that we want to build? How are we going to build it? Who has the context on that? What are the next tasks to be done, right? Software engineers spend probably like 30 to 50% of their time in the inner loop, but they're about to spend close to zero time in the inner loop as agents basically fully replace that. So they're all going to shred out to that outer loop of software development. And what that means is we need a whole new set of tools, right, to actually execute on that. And so what we're seeing is people are sort of pulling together a set of tools to create the new sort of platform for the outer loop. Platforms like Factory are our attempt to build that platform, right? But I think that these software engineers that are really like sort of 10x that of the next, what they're doing is they're figuring out ways to take the work in front of them, break them down into individual tasks that are parallelizable, and then setting off agents to work on all of these tasks at the same time. And they're basically doing code review as the bulk of what their time is spent doing. So they're looking at 8 different outcomes. They're reviewing the outcomes. They're saying, okay, that one's good. That one's good. That one needs more work. Here's what needs to be done. Go back and retry, right? And that sort of selecting and reviewing and decomposing tasks is a lot closer to what software engineers are going to be doing like 1 to 2 years from now.
It's interesting. So it's basically like this first principles thinking. I can see why it's so important, because for a software engineer to review the code, I mean, ultimately there's a risk of hallucination. There's a risk of these tools not producing the outcome that you want. So software engineers in the future there'll be a lot more, I guess, dependence on them to review the code to make sure that things are synthesized correctly and there's good quality code.
100%. I think that there's also going to be a huge resurgence in DevX and the sort of work related to testing and validation, right? Right now, even the idea of like writing unit tests or writing end-to-end tests is sometimes like a little bit more behind the scenes, right? People write tests, of course, but really, really strict validation is going to be so important for AI systems because they can use that feedback in order to ship higher and higher quality code where the human can start to trust the outputs a little bit more than they used to. You think about 50 years ago, right? When programming was very, very simple, like BASIC and COBOL were sort of the main ways that you'd build software. We were still able to build some pretty complex systems, right? Like there were still we put people on the moon, nuclear missiles, like there's a lot of hospitals. But the reality is you just couldn't build something like Salesforce 50 years ago. Now, the ability of an individual to ship some piece of high quality software that has nuance in it, that has lots of functionality, that runs really well, that is definitely going to be very, very possible, building that sort of level of software. But I think what that means is we're just going to start building even more complex software on top of that. So what is that equivalent of sort of the Salesforce level of complexity to somebody 50 years ago? We're going to be building that very, very soon, right? These incredibly complex pieces of software. And you think about what's required to get the sci-fi visions of the future. Like you just can't build humanoid robotics. You can't colonize space. You can't solve illness on humans without this sort of extremely complex technology. There's a lot of work to be done. I think that means there's a lot more humans that need to be involved.
Love it. You said something I want to quote. You said 50 years ago you couldn't have built Salesforce, right? It sounds like to me with this complex technology that we have now, this amazing tech, we're not too far away from something new coming about that could not have been built 5 years ago.
100%. We're going to build things in the next 5 years that would blow the mind of a software developer 10 years ago. I think you can actually start to see people realizing this right now. There's a couple of pieces of software recently that have come out that are pretty mind-blowing. I think a lot of the text, voice interaction models that I think OpenAI has one, Hume. A bunch of these companies have released sort of like real-time voice APIs. This is straight up sci-fi, right? Like there's movies about this from 10 years ago that are like projecting this like 20 to 30 years from now. And they're fairly competent, right? It's expensive, so distribution isn't there yet. But I think that there's a lot of things like that are sort of like mind-blowing that basically anyone off the internet, even fairly non-technical people, can sort of speak to a machine and have it build a machine that they can speak to that's totally customized. And I think that there's a lot of that's like literally the lowest hanging fruit. Like there's just going to be so much more from there.
When you think about it, you think about shows like Knight Rider from the 80s, and you think to yourself, like, could you imagine a day where you're talking to your car, right? I mean, going back to those days when they were making those shows, they were probably thinking, this is insane. Could you imagine this actually happen one day? Like that's the world that we're entering, this insane opportunity. What actually happens when AI enters the dev cycle?
There's really a couple of different ways that we've seen in the full software development lifecycle AI be really impactful. Most focus on the coding. In fact, that's sort of the angle that we've been talking about up until this point, is like coding specifically. That is incredibly important. And I think a lot of the like listeners and folks who have really encountered any AI coding tools will have some sort of sense of, there's an autocomplete when you write code, there's generation of code when you chat with an IDE. There's more advanced systems like droids and agents that can, actually go fully end to end, like think about the code, write the code, ship it, merge it. But then there are all these other things that developers do, right? This planning motion, right? Of I need to speak with a colleague to figure out who knows how this piece of code works. And then I'm going to take that insight in order to write a document that is a plan of how to fix that, an issue in some other part of the code base. And now we need to get that document sent over to product to make sure that they interact with it, right? That sort of messy, very human interaction, agents can be incredibly helpful with, because agents can go and find information. They can write it down. They can go act as that sort of like product voice, pull all this info together and help write that document after 5 minutes of you requesting it instead of after 3 or 5 days of process. On the maintenance side, incident response, when errors happen in production, AI can be the first responder because it's always listening, always on, right? So you have code review where agents can look at code that is about to get merged from a human and tell you all the places where it might have gone wrong or potential bugs. Documentation, right, is probably one of the bigger problems at a lot of large orgs. Docs are constantly out of date. You read something and it says, well, we do it this way. And in reality, you look at the code and it does it the totally opposite way. These are the sorts of places where agents that can comb through the code, look at the docs and say, well, there's a mismatch here, right, can be incredibly effective. So a lot of different ways that people are bringing AI into the SDLC, the software development lifecycle. In order to do true agent native development, you really need systems that can do all of these things with a shared sort of central brain or shared memory, shared context.
Brings us nicely to Factory. I'd love to learn from you as the co-founder, what problem is Factory solving in today's market?
The biggest problem that we see is across a large enterprise organization, there are so many sources of context and data that are required in order to be a high quality software engineer, right? And so the reality is all of that fragmented context means that AI systems that want to be fully autonomous just cannot be autonomous, right? And so we think that in order to solve the problem of fully autonomous AI software development systems, you really need to solve a bunch of these sub-problems. You need to unify context from across the org. You need to have the systems learn as they interact and work. And you need these systems to be available on every single interface and sort of like entry point that a software developer has. We looked at all the existing tools for coding 2.5 years ago. We looked at, it's autocomplete, it's a chat with your code base tool, right? And now we're still 2.5 years in and we have like CLI-based coding agents that are really good at coding in particular. You look at systems like IDEs that are sort of helpful for that coding workflow, and you can kind of retrofit writing into it as well. But there's still not a platform that really, at the organization level, not just the individual, but the actual company level, really sort of brings all of this information together, makes it available to agents, lets them learn, and then lets them work across the whole life cycle. And that's fundamentally what Factory is trying to build.
How does that work in an enterprise environment? When you sell the product to a large corporation, how does that sit into the ecosystem?
We really sort of think about this integration as a way for the droids themselves to have the ability to read information when needed and the ability to write information when needed. And then adding a layer of control, right? And sort of, you add role-based access controls, you have audit logs, you sort of centralize those touch points, and you end up with sort of like a very simple way of like, you install the platform at your company, you get it ready, you integrate once, right? You via OAuth, all very native sort of integrations. You get all that set up, and then no one at your company has to like think about this again, right? Compare that to MCP and a lot of other ways that you can connect to things. It's a little bit less manual. It's much more straightforward. And most importantly, it's much more secure, right? And so a lot of companies are willing to sort of make these sort of integrations and connections because they have guarantees around data, they have guarantees around privacy, and they don't have to do this sort of like fumbling around with MCP that where every user needs to install it separately, and auth is sort of an open question, and there's no audit logging or centralized capabilities. So it's quite straightforward, honestly. Like you jump in, most people integrate, and within 30 minutes they're ready to go.
Incredible. And you said something, it's more secure. Now that's a big factor in all these tools and technologies. There's so much, like the signal to noise ratio right now in Silicon Valley is pretty crazy. Like there's a lot of companies going out there and customers are looking at this and thinking, right, what do I need? But then they have another issue, and I hear this a lot, the security around this, because it is their data. Tell me, why is Factory more secure?
Yeah, totally. I think that there's a lot that we've done on this front in order to try and both, one, from the beginning, build out a system with security as basically the single most important technical sort of non-negotiable. But two, to also sort of drive forward the conversation on what it even means to have a secure agentic system, right? There's a lot of very, what I'd call it, classic things that you can do in order to make sure that you're building like the vast majority of your platform to be secure, right? So there's compliance stuff that you should have, right? Like we have SOC 2, we have ISO 27001, ISO 42001. We're compliant with a lot of the privacy acts. There's sort of that side of things. There's also the decision to support native integrations versus MCP. We do support MCP, but add a bunch of additional sort of control layers. Of course, also for like self-hosted deployments and like sort of how you actually want to deploy this sort of system, you give a lot of optionality there. But ultimately, all of this stuff is basically the same thing that you'd hear from any B2B SaaS company, right? That has thought about this for a while at least. If you put in a substantial amount of time into security, you'll end up with a pretty nice setup like that. The other half of it that is honestly a little bit just more interesting is the idea of building a safe and responsible autonomous system. There's basically no real agents that have reached sort of like mass distribution scale, right? And by that I mean tens of millions of people using it on sensitive data. Things that you have to think about are really different, right? You have to think about what are the risks that are possible when you have very capable autonomous systems. Who is to blame? Who's responsible when an agent goes off and does something wrong and makes a mistake, right? There's always sort of a blame chain that can exist in most organizations. When you bring in AI that's sort of at the org level, that's a question that you have to tackle. And so there's a lot that our team has done, both on like the actual technical side, like red teaming, building out threat models, figuring out ways to mitigate threats, and also on the more of the policy and like philosophical side of things to sort of define what it means to be safe and autonomous, and sort of work with other labs. Like we worked with OpenAI and Anthropic on sort of defining a lot of these standards.
So it's basically security by design from the first code, the way you built it, the way you thought about it. In your opinion, when you think about the market today, what challenges do we face as consumers of products? With all this AI around, all these tooling around, we think about security, but what other challenges do we have to think about?
I mean, this is probably one of the bigger things that we talk about with both customers and also just when we're meeting cool people in the space, is like, what even are the sort of feature set or comparables that we should be making? Like, how do we even think about what's good, what's bad? Security for sure, right? Super important. I think a lot of people just face a challenge in AI fatigue. If you're on X or Twitter or whatever, you're seeing a new release of a new AI thing every single week, and it's always the biggest thing that's going to change everything, right? And so you go and you find, oh, well, actually Gemini 3.5 Turbo Nano 7.5 V3 just came out, and that's actually going to replace, GPT 40407. And your head's just boggling, right? Like model versioning, should I even care about which model I'm using? Does it make a difference for a week? Maybe it definitely makes a difference 2 years down the road. And so I think that's one big thing. It's just the field is moving so fast, and AI researchers have bad taste in version names. And what that means is that there's sort of like a lot of lack of knowledge of what model to pick, what LLM to be using, how that impacts a decision. And then I think also there's, because of that breadth of tools, that sort of AI fatigue, you just at any given moment don't even know where to make a bet on maybe an early player or an established player. And so I think a lot of people sort of have these ideas swirling in their head every time they talk to anybody who's selling AI anything.
I want to take you, kind of digress from the topic slightly and take you back to the very beginning, right? As a co-founder, this is an incredible concept and it's timely positioned in today's market. Where did the idea come from?
The sort of origin is, my background is largely on the sort of like neuroscience, cognitive science / computer science side. Like I wrote my thesis on like brain fMRI, brain reading for authentication. Like I worked in a lab that focused on computational models of cognition. So it was very obsessed with machines and intelligence and how we can sort of connect or bridge that gap. I went to Microsoft and then I was at Hugging Face. And at Hugging Face was where I got to spend a lot of time focused on LLMs, and in particular working with enterprise companies, Databricks, Grammarly, Bloomberg, sort of like those larger orgs that were very interested in thinking about how do we build better LLMs? How do we fine tune LLMs? And arguably the biggest use case that I saw was coding. So it was like, how do we fine tune a model to autocomplete 5 times faster? And when you speak with these sort of engineering leaders who wanted to make this happen and you get at what they're looking for, it's like, well, we want to ship, way faster. We want projects to complete. We want 30 instead of 20 projects this quarter. And that's going to be really hard. So we need AI to help accelerate that. And you kind of think about that and you zoom out and you're like, okay, and code autocomplete is going to add 10 additional projects. There's no way, right? That's just not sufficient, because all you're doing is speeding up an individual serially, right? So the sort of seeds are there. I was prototyping building sort of agentic applications, although we didn't really call it at the time. And I met my co-founder, Matan, at a hackathon. We had known each other in college loosely, but not very well. And so we reconnected in San Francisco, realized we had a very similar vision of how things were progressing, and decided to sort of put our heads together. Sort of like the day after we met, serendipitously, he had cold emailed an investor. We had the opportunity to demo the sort of like a basic agentic system, the original droid, so to speak. From there, it sort of went on.
So you had a product, right? Like you had built something before you spoke to an investor.
Yes, we had built out sort of a demo of a Slack interaction that involved speaking on Slack to an AI system. It would take your input, it would write some code, and it built sort of a demo application. Honestly, it was very similar to stuff that's still coming out today, but powered by much weaker models. So it had way less ability to sort of correct from error and really get that full agentic loop.
What difference would that MVP look like today if you had built it today with the current technology set?
Great question. I mean, it's pretty funny because I think that one thing that's definitely happened is it's become much easier to build basic AI coding systems. And this is something that I think is sort of an open secret in the AI agent for software development field. But a lot of the core logic and sort of path for building an AI coding agent, like for example, a CLI tool like Claude Code or Gemini CLI, is basically like very simple and the same across all the coding companies. Like if you inspect Claude Code's code, or you look at Gemini CLI's code, it is not that complicated. It's quite easy to build. In fact, I'm fairly certain that given the same time that we did, which was about 7 days, you would easily be able to build like a similar clone of like an AI coding agent that was just as good as Claude Code. That's not to say that it's not an incredibly powerful application, right? The sort of like basic MVP at this point is very capable. I think that wouldn't be sufficient though to do the same sort of demo. A lot of the basics or the primitives that we needed to build back then have now been built out, or there's even maybe companies that provide. You can get virtual machines as a service that your agent can connect to, and you can get all of the context compression and the memory natively in the LLM APIs. And so there's just a lot of stuff that's been built that I think helps make these things way more powerful.
So if we look at the current landscape today, earlier on the show, we talked about how, 50 years ago, you couldn't build Salesforce, right? Today, a basic MVP is probably a quite a complex MVP from maybe 5 or 10 years ago, maybe even 5 years ago. Is that quite accurate to say?
Yeah, I think so. I think that, and it doesn't need to be necessarily complexity for the sake of complexity, but I think that it's so easy to build, something that now I think the bar is just raised significantly on anything you build. And this is something we talk about a lot with writing as well. When you write a PRD, you can get a PRD or a technical design that is pretty much just as good as what would have taken you a week in like 10 minutes. Does that mean that we should just sort of settle for the thing that took us 10 minutes, right? You have a week, make it better, right? And so I think that that's sort of the mindset that we all have to have, is the way that we get this level of, in order for us to solve those big problems I was mentioning earlier, right? Let's colonize space, let's solve disease, let's expand our lifespans, let's, make it so that every human being on the planet is free of sort of like physical suffering, right? Like no hunger, no access to clean energy, all that kind of stuff. In order to solve big problems like that, you are going to have to, for sure, raise the bar on what like MVP, what the minimum amount of output that you can produce is. And I think that may be a little anxiety inducing if you're sort of right now in the building stage, like looking at this thing and it took you a long time to build and you're like, oh man, wait, what does that mean? But I think all that means at its core is there's going to be a lot more competitors, to be honest. Like that's probably one big thing, is you're going to build something, and if it took you one day to build that thing, then you can bet that there's probably 50 people on the internet that you've never heard of that already built it a week ago. And so what have they done in the meantime, right? I think that's sort of the mental model that you need to have.
It's exciting. I mean, that's what I guess Silicon Valley is about, right? Like this innovation and competitive edge. The other, I guess, key area that I'd like to discuss in relation to Factory, how did you get that early customer buy-in? And when I say how did you get it, I'm really quite keen to understand, with a product like this, what was the initial feedback and what was that aha moment?
We spent a long time iterating with customers in order to figure out what the ideal sort of interaction pattern and form factor and capability set was. The first customers that we had were a combination of early stage startups that were willing to take a bet, right? It was introductions from investors and people that we knew, from mid-stage companies that were willing to sort of be design partners. A lot of it is just spending a lot of time and energy finding these people, right? Like there's no sort of cheat code or growth hack, I think, that solves this stage, which is when you're early building, you need to have an incredibly tight iteration loop. If every like 3 to 4 weeks you haven't decided like what we're building is totally wrong, we need to scrap it and start something else, or you haven't gained like a significant degree of conviction that the path that you're taking is correct, then you're probably not spending enough time on getting these customers. We iterated so much in the first 6 months, and the product changed several times pretty substantially. We ended up landing, and this is also sort of an interesting tidbit, we ended up landing on something that it then took us another year to realize was not the correct form factor for larger scale deployments, basically. And less, like, basically we honed in too much on a persona that was very forward thinking. And then when we sort of went broader to a larger group of people, it became very clear that that was way too sort of forward thinking of an application, not necessarily wrong, but definitely wrong at that time. And I think that, funny enough, now we're bringing some of the UX and ideas that we had back then into the product today, because it now it feels like it's a little bit more of the correct time now. But we sort of had this sense of what was right. We went at it. We spent a year and a half basically building towards something that was pretty much the wrong version. And so then we changed it significantly, and that's sort of how you land on the current Factory platform.
How much of that initial idea when you sat with your co-founder, how much of that concept is what the product is today, and how much maybe has it evolved and changed into something completely different?
I mean, it's funny because we changed the code base entirely from like Python to TypeScript. So 0 lines of code from that original code base remain, right? For all intents and purposes, it's actually going to be extremely similar to the original idea in a very short period of time. And I think that is exciting because the original idea was very ambitious. And it was something that I think we underestimated the sort of necessary prerequisites. And we've spent a long time building out those prerequisites. And we're sort of there. I think that original idea of you should be able to speak with AI systems that can execute tasks from any interface with that shared context and shared memory and learning, that is possible. And it's something that we've built out that we're really excited to sort of release more broadly. But even today in the current platform, right, you have all of those pieces, right? We have the agents that you can speak to, the droids, so to speak. We have that shared context, that shared learning, and we have some of those interfaces built out. But I think that sort of original, like Slack, for example, interaction just wasn't, you didn't have the ability to zoom in a precise way on what the droid was doing. Engineers can't just rapidly pivot their workflow to Slack. So it's the wrong sort of main form factor. You need something with a little bit more control. So I would say, funny enough, it's surprisingly similar to the original idea.
Swings and roundabouts, right? Where you kind of go through that journey and now coming back to it. I'd like to tap into one or two use cases of Factory, but before I do, that early stage, once you've got the funding, you've got the term sheets, you incorporate, you're ready to go. The design partners, the funding. What would you say for you and your co-founder was probably the more challenging or more difficult part? Was it to get the more sort of the volume of design partners and potential customers, or is it the funding stage?
Fundraising is just really more annoying than anything. I think it's stressful, and it feels like this sort of like necessary, I won't say evil, but like necessary part of the process in order to build a team. By far the most energy gets spent for us though on the like customer product iteration loop. That's where 95% of my mental effort was and still is on any given moment, is just what is the value, trying to identify the value that we can deliver to customers, making sure that they realize that same value that we think they would, making sure our personas match the value add, and then making sure the product itself reflects sort of a growth trajectory to only scale that value out, right? And not lose it at some point or lose it in comparison to another offering. So that's definitely where, as a founder, I think you should be spending the vast majority of your time until you have unambiguous sort of like selling ability. Like when you can walk into a room and show someone something and they instantly say, we don't even need to try it, let's just buy. Like maybe then you can start to think a little bit more about purely like marketing and fundraising. But I think in the meantime, the vast majority of the effort is just on this product iteration loop.
Yeah, no, getting there is definitely, without a doubt, from what I hear from all the founders that I speak with, is critical before you think about anything else. That product market fit, and that's an ongoing journey; it never ends, but it's getting there. As far as like use cases, tell me, it's a very interesting and incredible product that you're building, and clearly solving a big problem. But what would be a unique, typical use case that you're seeing with one of your customers is truly delivering great value?
Probably the one that comes to mind is migrations and very large scale refactors. So this is when a company comes to us and says, look, we've got, 4 months and we've got a legacy code base. It's our second largest code base at the company. Every single person that worked on this code base is gone. We lost them all. And it was our Italian contracting team. So the whole thing's written in Italian. None of us speak Italian, right? And so it's like, I'm not even joking. This is like basically a real example, right? It's like, so you have these real sort of messy problems of big code base, no idea how it works, and we need to replace the entire thing. And we have like a couple months to do it. This is sort of where platforms like Factory, I think, really showcase the difference in workflow and that parallelization, how that can turn something that would take a long time into a significantly shorter time, right? I'm talking days instead of months. And really the way that workflow is different is you sort of think about what, if you went right now to like a professional services sort of organization and said, please do this migration for us, right? They would document all of the artifacts of the code base. They would figure out all the databases, the tables, how those all connect. They would outline the structure. They would create a plan in multiple phases of how to migrate. They would bring that into your ticketing system, divvy it up into a bunch of different individual tasks. This group of people works on that. This groups of people work on that, right? That whole workflow can sort of be orchestrated by effectively like 1 to 2 people, where you are having agents go in and say, go and document the entire code base. Now create a diagram of all of the databases and tables. Now ingest these 2 documents with access to the code base and create a migration plan. Now go create a Jira epic and create tickets for each individual item with dependencies so that I know what can be run in parallel and what requires the other one first. Now you spin up 20 code droids, have them just execute on each task, and then you just start reviewing, right? That sort of workflow is just, 1, obviously different from how engineers today work, but 2, it's a parallelization that is just only, that is just definitively going to be faster than any serial work that a group of people do.
I mean, I was just trying to find a name of the oldest code. Maybe this is the oldest, I don't know. But like, let's say you go to a legacy company with legacy code, like a really old bank.
Yeah, like COBOL is common.
That's exactly what I was trying to find. Whilst you're talking, I'm trying to figure out like the oldest code possible. COBOL is common. The people that built it probably are not even around anymore.
Yeah.
I mean, I'm just trying to imagine the level of disruption to the customers, the users. But you're saying that not only is this going to be more efficient, but it's faster and you need less people to do it.
Yep. There's truly insane volume of code bases that are, because code, I think that sometimes because code is so mechanical, people sort of assume that if you kind of leave it alone, it'll just keep working. And the reality is code degrades unbelievably quickly. A lot of these legacy systems have been designed to last for a long time, but you have COBOL, you have all these systems that, run like, I don't know, 10% of the world's like financial transactions. And those systems are going to blow up in like a couple of years. And so this is a real urgent problem for a bunch of different companies. And really, it might not even be a solvable problem without agents. And so a lot of the projects that we work on with droids and the factory platform end up being modernization and sort of like large scale migration.
If this technology didn't exist, how many people do you need to do that type of work?
A project like that where it's slated for, let's say, like 2 or 3 months and you're able to do it in about a week with 2 people probably would originally have taken a group of maybe 8 to 12 people. Yeah, like I said, 2 to 3 months.
Wow. Which leads me on to the name Factory. I'm starting to see why you called it Factory, but keen to hear from you.
The sort of like origin is sort of a couple of different sources. The first is the idea of the factory method, a common like software pattern. The real sort of like ideological behind the scenes, though, is this idea of, as there have been a number of technological revolutions, right? The Industrial Revolution, you always hear, like Richard Arkwright is this guy who sort of designed the first factory. But I think Henry Ford and a couple others are the ones that really like nailed factories, right? You sort of have this idea of taking this messy artisanal process of like, oh, I'm going to like, do my thing. And then maybe I'm going to walk across the room and hand it off to somebody else. And there's all this domain knowledge that's stuck between the glue of, and then you go to a factory and it's like you build an assembly line, right? And you have this assembly line with a very specific set of responsibilities. You have, machines or people that hand off from one to the other. They do just their responsibility. And you sort of build a process, right? And that enables a new sort of scale. The only software orgs that really operate like this are very large software orgs who have figured out how to industrialize the production of software. The vast majority of companies do not have this sort of process. They don't have this sort of automation. And we think that droids and AI will allow all sorts of companies the ability to have the sort of process, automation, and scale that enables them to ship significantly faster, right? There's sort of a lot that goes into that. There's a Henry Ford quote that we also really like that sort of relates to this idea of the factory, but factory, and sort of also why we take a sort of different approach, which is if I'd asked people what they would have wanted, they would have said faster horses, right? And I think that that's sort of this idea of innovation and radically different sort of interfaces are not natural. They don't really sort of bubble up in normal conversation of what people want or expect out of AI. it requires sort of a more fundamental rethinking of what's possible. Factory's trying to do that.
It sounds like you are doing that. That's awesome. I have one last question before we sort of wrap up with our theme of the show, which is a book recommendation. But I have one last question for you. This must be a very, very exciting time for you, right? You're in the midst of building something and it's working, and it's you got the customers, and it's an exciting time. How do you compartmentalize all of this, right? Because as a founder in Silicon Valley, you've got a team, you've got investors, you've got customers, you've got a product that you're building. As you said, all your mental power is how do I make this better and bring more value to my customers. Every so often, I like to ask my guest is, how do you compartmentalize all this? How do you find your time to be able to just sort of relax and whether it's the gym, whether it's family time, what do you do outside of work? And the reason I ask this question is a lot of our listeners are founders or soon to be founders, and it's a tough gig to be a founder. It's not easy. It's you have a co-founder, which is amazing, but even as co-founders, it could be somewhat of a lonely place. How do you compartmentalize all of it?
Yeah, well, I appreciate you asking the question. I think it's an important thing to talk about because San Francisco in particular, Silicon Valley, definitely has a very go sort of mentality, and I think that if you don't have some sort of system, right, I think it can be very overbearing. That being said, the reality is that if you're thinking I am working a lot, like I don't have a lot of time, you're honestly you're not crazy, because that sort of is the gig. Like I really do spend the vast majority of my time thinking about sort of the space and area that we're building in. Now, I think importantly, I actually really enjoy like a lot of the topics, the idea. Like in my free time prior to Factory, I would like be building little things and prototyping and spending time reading about technology and about the future. And so a lot of like my sort of like leisure time is luckily like very tied to the general direction of what we're going on. But I think, there's a lot of like process and system that I've built in. Like, for example, going to the gym to sort of like set that as a set time. My girlfriend is a resident at Kaiser Oakland. She spends a huge amount of her time working, but we were able to sort of match schedules and find time, go hang out and like, see a movie or something like that, go to dinner. And so I think that there's sort of these releases that happen, and opportunities to hang out with friends, right? We're right next to the Giants stadium, so we go to a Giants game, right? Oracle Park. So there's a bunch of stuff like this, right? That I think you can get, but I think you probably just want to make sure that you enjoy the topic of what you're about to spend a huge amount of time in. That's definitely the most important thing, because if you find yourself really not enjoying the general topic, then you won't be able to find any solace in what you're doing, right? So I think that that's probably the most important thing.
I love it. Well, thank you so much for sharing that. I don't ask the question often, but sometimes I wonder, so it's good to, and as you said, it is a very important question. One last question I have for you as we're getting to the hour. I do appreciate you making the time today to be on the show. One of our themes on the show is to always end the show with a recommendation, a book recommendation in particular. The reason why this is important is, as you said, I think we're part of this amazing ecosystem, and it's a great time to be in tech as always. But AI is incredible and Silicon Valley is awesome. But whether you're an engineer, whether you're a founder, whether you're soon to be founder, or you're just someone who really loves to learn and read, is there a book that you've read, one that you've truly just learned a lot from and has truly resonated with you? What would that book be?
One of my favorite books that I always recommend, it's actually in our like Factory sort of like reading list as well, is The Thousand Brains Theory by Jeff Hawkins. What this is it's basically a book that suggests, it's a book that explains a theory that suggests that your brain sort of contains thousands of these independent sort of like learning units. You can call them cortical columns. It's sort of in your neocortex. And that sounds like really sort of like, technical and neuroscience-y. But the sort of implication here is that rather than thinking of your brain as sort of this like unit, this like big thing that just is you and processes everything, the theory sort of walks through this idea that maybe there's actually sort of thousands of these mini brains that all have these independent models and views. And the way that you operate is these systems basically like reach consensus. They say, oh yeah, like, this is what you're seeing, and like, this is how you should be, and this is how you should think. And I think that the first of all, it's just a well-argued thesis, but second, the implications for both sort of all of these different ways that you think about yourself and your own identity and who you are and what it even means to be you, blended with the idea of the systems that we're building, right? AI and agentic systems. There's sort of like this pathway towards imagining very human-like reasoning systems that are capable and sort of mimic the sort of system that we are in a way that I think is very profound. Because if we really can build AI systems that mimic what we are, then it sort of has like this broad reaching implication for what it means to be us. And so I think that all of this stuff is just fascinating. And so I'd highly recommend reading. It's actually like very consumable. It's more like pop science written. And then you can go read the papers afterwards if you want to go deep.
Love it. That was a great recommendation. And it has been a privilege of mine, an honor to have you on the show. Thank you so much for making the time. You're building an amazing company. So thank you for, your contributions to Silicon Valley.
Thank you for having me.
No, of course. It was I learned so much and hopefully we can do it again in person. But yeah, thank you so much. And I'm sure we'll speak soon.
Appreciate it.
Take care.
This podcast was brought to you by Serrana Labs and powered by Harrison Clark. At Harrison Clark, we're at the heart of Silicon Valley's evolution and at the intersection of search and venture, funding the companies shaping the future and connecting them to the most elite cloud, data, and AI talent. To learn more, visit harrisonclark.com. If today's episode challenged your thinking, then share it with someone who's driving innovation. For even more insights on achieving product market fit, subscribe to our newsletter, The PMF Playbook, where we break down the journey from zero to product market fit. Visit thepmfplaybook.com. For more episodes, follow us on social media or visit insidethesiliconmind.com. Until next time, stay curious, stay consistent, and stay inside the Silicon Mind. See you soon.